Welcome to DJNTV and Tuesday Night with Ben Stowe. Now introducing the one and only Ben Stowe.
Yeah, baby! Yeah.
So you were wondering what would be the most fun you could have on a Tuesday night, and you were looking at all the options, and there were lots of options. You could watch reruns of your favorite Star Wars episodes. You could watch Big Bang Theory. You could watch old Frasier episodes. But no, we've got something better than all of those combined. And that's Tuesday Night with Ben Stowe. The Sick Edition.
Yes, right on cue. No place I'd rather be, actually, than hanging out with all of you. I mean, other than in bed. That was my other choice. But anyway, here I am. I've not taken a sick day in 2 years. And I guess technically today didn't count either because I worked all day. But anyway, here I am. So we've got a nice, easy, soft topic that won't involve any math, right? Much. Okay. Well, at least it's power, which is mostly algebra, not logarithmic calculations.
So we're good with that. We're good with that. So for those of you, we are concerned about your safety and your health. So if you could all go and put on a mask right now and come back, so that way you don't get sick.
Pretty sure you're safe over the internet. I don't think it can travel across the electrons.
Well, but we do have high-speed internet now in Minnesota, so it's better than our first dial-up shows we did. But hey,
computer virus is different.
Different. See, you learn a little bit every night. So
I'm the tech here. The tech.
You are the man. You know what you're doing. So tonight we've got questions that have popped up for the last number of years. We've done shows on electricity numerous times, and there's constant questions and fallacies, misunderstandings when it comes to the little things that come out of the electricity that comes out of that wall outlet right there. So tonight we're going to talk about a lot of some of those questions. And if you've got something you'd like us to you've got a burning question, put that into the chat, and that should propagate to the computer here so we can run that through during tonight's show. Tonight's show will be a full show going from, till almost 9 o'clock. And then after that, they'll have the Tuesday Night Music Show at a different spot on our channels. And we'll get you that link a little bit later. But we're going to cover ground tonight. Could be groundbreaking.
So was that pun intended?
Could be groundbreaking.
Yes, be grounded. That's very important.
It is a big part of it. So actually, as long as you brought it up, let's just start right there. For the people who talk about buzzes, one of the quick answers that people will share online is, okay, so I've got this buzz in my system. How can I get rid of it? And they said, you can just use a cheater. First off, define what a cheater is and tell us 17 reasons why it's a bad idea. Go.
I just tell you one reason you can die.
No. You got to tell us first what it is, and then.
Oh, right. Then. So I have to confess, because I am not feeling well today. I've given a lot of presentations live, and I punted tonight, and I have a whole PowerPoint slide deck that is just sort of lurking in the background here. And luckily, cheaters are in it. So give me a quick moment to locate those in the presentation.
And see, this wasn't even on the list of what we were going to be talking about tonight. But
it's not. But I knew you were going to throw a bunch of curves at me anyway.
It's coming out somewhere. It's going to be there. Oh, funny.
All right, so let's do this. I have 2 slides on grounding and cheaters, and I'll just share these and see if I can run through them quickly for you. So here we can see an ungrounded receptacle. We're mostly familiar with the ones that look like a smiley face, whatever. Like kind of like what you see, on this guy.
Yeah.
This one you'll notice doesn't have that.
Doesn't have it. That would be the Northern Minnesota VFW outlet.
Yeah, and a lot in the Northeast, but this became illegal to install in new construction back in the 60s, 67, I think. Somebody can look it up and correct me, but it was in the mid-late 60s. So what we have is our neutral conductor, we have our line conductor, and then we have our safety ground. And you would say, where does that ground go? Now, I realized the question was on cheater plugs, and this is what cheater plugs were designed for. They were not designed to remove a ground. They were designed to add a ground. So when we are using to remove a ground, 2 things here. 1, we're doing something unsafe. And 2, we're doing something illegal. Actually, it is illegal to purposefully remove a ground. And the NEC, the National Electric Code, specifically says that an objectionable current, which is their way of saying noise, is not a sufficient reason. Now, you might be thinking, oh no, the police are going to come. No, I'm not saying that. But the thing is, you could cause real harm to yourself or worse, others, and then it will be a serious problem because you've broken a law and caused injury or death. That never ends well. Anyway, so let's take a look. So this is one way people would do that, rip off the ground plug, right?
I still have PTSD from that happening to one of my expensive cords.
Oh, so bad.
Oh.
You know, I mean, just so bad. And then, whoops, then there's the cheater plug. Now, what I want to point out is if you look at the cheater plug, because you'll say, well, hey, okay, smarty pants, if these are illegal, how come, you know, you can still buy them in Home Depot? I didn't say these are illegal. These are not illegal. Using something to lift or remove a safety ground is illegal. This device is not illegal because its intention, as we looked at in the previous slide, is to add a ground. And if you look, you'll notice this tab here that would line up with where the screw is on the plate in the hope that the grounded box, which would be hopefully bonded to the grounded conductor, which is the neutral, that we could create a secondary path to ground. So without getting all, you know, whatever, the whole point of these things was actually to add a ground, not to remove it. So don't use that. So if you have a noise in your circuit, there are other ways that we need to look at to remove that noise. And we can use like galvanic isolation, a transformer-based device like an ice cube or a direct box or something. But what we don't want to do is remove the equipment safety ground on the power side. There's lots of other places we can go. By the way, excuse me, by the way, there are a couple ways you can go about using an ungrounded outlet, and that is to use a GFCI, a ground fault circuit interrupter, and there's portable ones like this that you can use, and both of those get the smile of approval. So
smile of approval, nice.
Yes.
Nice. Okay, we've got some questions coming in. Thank you guys, Joseph, Jeff, and DJK. Thank you for joining us. We're going to put a little break between the questions, so then for edit purposes, because then we're going to break these questions apart, so that way we can refer to them later. So we're going to get to our question number 2 here.
Oh.
Now we're live. Hey, question number 2, Ben. Someone, Joseph put this one there, was wondering if there was some sort of a magic device. Magic widget is what he said, which I absolutely love that terminology. But anyway, something that we could plug in to an outlet and get some information from that before we, licked our fingers and just stuck our fingers in there, which tells you something too.
Well, that's one way to do it.
Yeah.
I mean, I guess it depends on how good you are at sensing voltage, It's like, well, it feels like 120. I don't know. But so there are 2 widgets. One is going to be probably more useful, I think, because it tells you more information. But there's another widget that I carry with me, like literally everywhere. I have about 6 of these things now. This is the most fancy widget I have from that. And you'll notice many of you have seen these little testers. You stick in an outlet, it's got the lights on the end, and you'll say, wow, that one's bigger. Yeah. I feel like there's a joke in there. But anyway, so this one is also battery powered, and it will tell me various things about the circuit. And I'm going to show you this one first. So here we can see, if you can see it, it says open because it's not plugged in anything. So if I plug it into my circuit, now we can see that it says, okay, that is correct. And you have to let me know when I get the angle where it works.
There you go, right there. See it? Oh, yeah. 123 lightning bolt.
Yep. So all this is telling me, and it's nice that it tells me the incoming line voltage, and it also tells me the outlet was wired correctly, and there is in fact a ground. This one will also test GFCIs. It will time how many milliseconds it takes to trip it, and that's kind of handy. But in terms of magic widgets that will tell you almost everything about your circuit, because I bet there's one thing you want to know that it doesn't tell you. I love these things, and I gotta say, John, I've been saying this for years, and I've just sort of started to accept the fact that it's not going to happen. But with all your connections, how do I not have an endorsement with Klein or Kilowatt? Like, how am I not?
You would think, because
you would think.
Yeah, we've talked about their gear a lot.
A lot. I've sold them a lot of stuff. Anyway, not even a baseball cap. I don't wear hats, but anyway, But anyway, I'll take free gear. Nope, guess not. All right, I buy all my gear, so it is whatever.
Yeah.
So this is called a Kilowatt. And you can get them pretty much anywhere kilowatts are sold. And it doesn't matter where you get them because I don't get paid for it. So not that I'm salty about it. Just saying.
Not much. It's kind of sort of not. Maybe a little bit. Yeah.
So what we can see here, there is line voltage, right?
Yeah.
I can also change, and I can look at the amperage. And I don't have any load plugged in here, but if I did, I would see how much current it is drawing. And more on that in a minute, but that's important to know. This will show me both watts and volt amperes. And you'll notice they both say 0 right now. Again, I have no load. So a watt being real power, volt ampere being apparent power. And then I can also look at the frequency of my electricity. And in the US, it should be pretty much 60. And then that's probably what it says. Yeah,
Yep.
it's 60. So anyway, this is kind of a handy little gizmo because we can use it to measure low current loads. It's a good way to find out how much power your gear takes. It's a good way to make sure, it's just sort of like a little miniature meter. Now, if you plugged in and the frequency was wrong, what can you do about it? Not much.
Yeah.
Unless you're on a generator. Most of the gen sets that we work on have the ability to adjust the frequency, and we can go in and make sure that's locked in right at 60 so that everything, clocks correctly or cycles correctly. The other, this is the magic widget or gizmo, but the other, I think, essential tool is just a meter. Just having a good multimeter everywhere you go, and knowing how to use it, of course. So,
And this is almost what's in Ben Stowe's bag. I mean, we just did a little sample of that show.
yeah, in fact, you'll see some redundancy. And yes, I know, of course, we have a lot of friends from Rachel's new group, the Help Desk, watching, and thanks for joining us. And I posted a video of the bag that we did like 7 years ago. And of course, I have cases that I fly with and also my laptop bag. And they do very much mesh together, but also there's a little bit of overlap. I do have some of these devices in both places so that if I only have my laptop bag with me, that's how important these devices are, that I still have them.
For
And
sure.
then I have the bigger, better ones in my tool case that I can fly with.
Yeah, it's amazing how many times you find yourself utilizing those, because I've got those in literally all. Yeah, I think I've got all through. I don't. Mine isn't. My circuit tester isn't quite as cool as yours, but I've got.
Well, and I have one more widget. Since we're
There's
using
the last one. I was wondering if you were going to pull that one out.
Yeah, so this is called a non-contact voltage tester, and this one will do both 12 volt to 1,000 volts, so I can do power limited circuits, but it will also do, there's line voltage. And what's cool about this is, whereas the other ones I have to touch conductive live parts, meaning the metal parts, the parts that can zap you, I don't have any conductive parts on here. All I have to do is basically in fact, I don't even need to stick it I can just touch it to the wire.
The wire, yep.
And it's telling me, hey, you've got electricity there. This one also has a flashlight, which is kind of handy,
Oh.
So,
Cool.
my other one has a laser. I don't know what to do with that. But anyway, I have about 10 of these things, and my wife's just accepted the fact that I have a problem because every time they're on sale, I get more, but they're just kind of a handy tool, oh, this outlet isn't working. Wonder why? Well, okay, now so.
Yeah, that the final little the electricity presence tester, that one actually saved my butt because I was going to be putting in a ceiling fan and I had shut the circuit off, and I just, as redundant testing, went and took that device and found out that there was something bleeding in on the ground wire.
Oh, absolutely. Yeah,
And,
you
oh
can
my
have that,
gosh.
absolutely. Or you can have something inducting across on an adjacent conductor. And that's one of the gripes that one of the instructors I had in an electrical class was, he said, well, there's false positives with those. True. And I'd rather have that than a false negative.
Yeah, well,
know?
and there indeed was, because when I then brought my circuit tester out and did across, there was electricity present in that ground wire because there was a light fixture that was wired improperly just down the line, and I had no idea.
So scary. Yeah, you could have been done for. Yep.
Yeah, it's just one of those things. So definitely, they're good tools. So let's put a break in here, a quick little, and then we'll be back with our next question. We are back. All right, next question, Ben. People have been talking about surge protectors and protecting their gear. Are all surge protectors? I can go and see, you see them from $10 up to whatever. Are they all pretty much the same, or what kind of, what's the differences? What should I be looking for when it comes to surge protectors?
Well, very little of anything in the world is the same, right? There's very little times when you can say a $10 thing is the same as a $1,000 thing or something. And, there's sort of that get what you pay for mindset. A couple things that come to mind here. When we talk about surge suppressors or transients, or TVSS would be the technical term, transient voltage spike suppressor. There's a lot of different ways that can be done, and the most common way and the most inexpensive way is using a metal oxide varistor. I've got some pictures that I'll bring up here, but I want to mention this actually happened in my own hometown, where a fire was actually caused by a little inexpensive plug-in surge suppressor. And I'm not sure the exact circumstances, but MOVs are sacrificial devices, and this one, I don't know if this one was actually UL listed or not, but the plastic on it burned, and I don't know the whole story, but I know that was the cause of the fire. So no, they're definitely not all created equal, I guess is my point. And in this one tragic incident, obviously this isn't a rampant problem or they would be banned, but in this one instant, it actually caused a fire. Which, by the way, when we talk about, obviously shock is a serious concern, but fire is actually the number one concern when it comes to electricity. And the National Electric Code is published by the NFPA, which is the National Fire Prevention Association. So anyway, for those of you who are just watching these in individual snippets, I've had a cold for the first two snippets, and this is the third, and I still have it. So here we go.
So Ben, maybe we need to define a little bit what a surge protector actually does, because it sounds like it's a kind of a sacrificial, almost like more like a fuse is what it just sounded like, what you were describing.
It can be sacrificial, and that's. I wonder if I have. You know what? So I'm going to go to this slide deck that I have, and I honestly don't remember what I have here for slides. So I think we're just going to go with it, and we'll all be surprised together.
Nice.
And I'll try to do my best to illustrate. I know in one of my slide decks I have a picture of an MOV that has exploded. I don't know if this is it, and I do apologize. So on the left here, we can see a graphic illustrating an outlet, my line conductor, neutral, ground. And here we see the schematic symbol, excuse me, for an MOV. And here we can see the MOV. And the way this works in most cases is we put the MOV, a metal oxide varistor, between the line and the neutral conductor. And if the voltage potential gets too high, the MOV basically opens like a gate and allows that current across. Now, anybody that's ever touched anything between the line and the neutral conductor knows what happens, right? Bam! The breaker trips and sparks and whatever. And that's what the MOV does, almost in essence on purpose. It then relies on the breaker, which is the overcurrent device, to end that in that case, because what it has done is it shunted that voltage to the grounded conductor. Here we can see what that looks like in a schematic sense, and I've used red instead of black just so it show up better, but in your household wiring it would be black, white, and green. And now we can see a secondary MOV between the grounded conductor and the ground, and the neutral and the ground, as it were. And you might say, why is that? And because we may have problems here with excess voltage landing on the neutral now because of the way we're doing this. And many will add a third. So we've got kind of this way of dealing with these significant surges. But typically MOVs are a one-shot deal. The MOV blows up, prevents that spike, hopefully from getting to your gear, and that's the end of it. They're typically sacrificial. And here we can see this is the inside of a rack mount power conditioner. I say that loosely. It does have some coils and chokes in it, I think, something that does some basic noise abatement. But you can see there are those three MOVs in this inside of this. There are other systems, though, then that happens to be a Furman unit. So you'd say, oh, okay, so Furman is crap. Not necessarily. Furman also makes, like their Classic Series and their Series 2, and you could say, wow, there's a whole lot more hardware in here. Yeah, that is a non-sacrificial surge suppressor here, that it's designed to handle these over voltages in a way that doesn't cause equipment failure. Failure of the device itself. These things should be able to take a couple hits and keep on ticking, So now, what's right, what's best, you can see there's a significant difference in the depth of the chassis. There's a significant difference in cost. There's a lot of reasons where maybe we wouldn't necessarily need the bigger one or want the bigger one, but there's a very, very clear difference. And this is just within one brand. So we can see within one brand, there's a very clear difference between two models that on the outside look pretty much the same.
Sure.
And I don't think I have any more slides on surge. Nope, I don't. Okay.
So when it comes to the surge protector, is it protecting from the load? Like if I put too many speakers on and I am taxing the power coming from the wall, because I'm basically only getting so many watts from the wall or amps from the wall, and I'm asking for, you know, 120% of what's available, so I'm overtaxing it? Or is it protecting from something coming through the line and all of a sudden the voltage is jumping up to 140 volts or 180 volts? Which way is it protecting?
Yeah, so the surge is something that exists in the line. A transient voltage that comes down the line that all of a sudden that voltage is way too high for whatever reason. Lots of reasons it can happen. The other situation you're talking about, I have too much load, I'm drawing too much power from the wall. That's going to cause a trip to my breaker. The circuit breaker, which has a maximum allowed capacity, when that capacity is exceeded, and there's different excuse me, there's different capacities and different trip times, but when that capacity is exceeded, then that breaker is going to open and break the circuit, and that's why it's called a breaker.
Okay. So the surge protector then, of course, in the household situation, we just had a new water softener, and they were recommending putting a surge protector on because he was saying lightning is a huge killer of appliances, and that would be because of that coming through the line.
They're even talking in the new NEC about household surge protectors that will exist to protect the premises. So they're beginning to talk about surge suppression systems. And again, there's lots of different types. You know, this could be a 4-year show, electrical engineering course, but there's more than just one type of, surge suppressor. So yes, surges can be a real problem.
Excellent. Let's jump to our next question here tonight. And again, we got a lot of folks in the chat room, so thank you for being with us tonight as we're going through different questions on electricity. Let's jump next. All right, next, Ben, when I've been playing in different places, whether it's venues, schools, specifically schools, sometimes they've got different jacks. They don't have they've got the 110 jacks, of course. It might be a 20 amp, it might be a 15 amp. Most of the time it's a 20 amp because it's commercial property. But then they have something that looks like a clothes dryer jack on the wall. And I've seen 30 amp, like camping jacks type things up on, and 50 amp, and then of course the 220. Is that something that, as a novice, person, should I be buying adapters to utilize some of those, or what kind of dangers could I get into with that?
Well, there's a lot of questions in that last question alone. As a novice person, no, I don't think so. And simply because the risks outweigh the reward. But you had me at yes right up until that. Is it a good? Sure, I use distros all the time, and I use large disconnects all the time.
Define a distro for those who aren't familiar with what that is.
Yeah, I will. And I think maybe I'll just kind of define that kind of in sequence here. But I think the other key thing is that I'm not a novice, right? I'm a licensed electrical contractor. I'm knowledgeable and I'm experienced, but that doesn't mean I think that you have to be that to use these devices either. So let's say that all the people that are watching are people that are striving to learn and they're looking to grow. So their level of novice is going to, fade with time, right?
Sure.
So without addressing the novice part, let's just talk about what these devices are.
Sure.
And then I guess everybody will have to make their own risk assessment as to their level of comfort. I certainly wouldn't recommend anybody go make their own. I think that's the one thing I would just say, look, that's a no-no, So let's talk about what these connectors are first, and then we'll take a little bit of a walk through the different types of electrical services that exist, and then we'll talk about some distros. And I'm going to kind of pick off some of these slides from this existing deck I've got, so let's just dive into that. So, okay, you can see this chart here?
Mm-hmm. Yep.
So these are NEMA connectors, which is basically an electrical manufacturers association. It's kind of how we classify things, and almost everybody is familiar with a 515. It's the outlet in your wall at home. If you're watching from the U.S., those of you who are not watching from the U.S., sorry, Google it. But here we can see. Back up here. I'm going to turn on my annotations for a second, and here we can see There's that NEMA 515R, right? So everybody's seen one of those. And that's just the NEMA classification for that particular connector. And you can see how these different connectors are. We talked a little bit about, dryer plugs, like a 1450 or 1430. So those are going to be the most common typical ones you're going to see. So let's dive into those. Something else you might see in bigger venues is something that's very typical for me, something that just really makes me happy now is, when I see cam feeders, because these are very high amperage, 100 amp, 200 amp, 400 amp, three phase. This is definitely not novice, definitely not for the faint of heart, but you can run a small trailer park off these. I mean, you got a lot of power here. So when you have a big concert or a tour rolling through, we're probably going to use a couple of these maybe, the reason I throw this in here, and you might say, what's that got to do with the dryer plug? Well, because they're all cousins,
Sure, yeah.
once you jump in the rabbit hole, it's just a little bit further down, so, it's, we all go on that journey. I didn't come out of the womb with an electrical license, right? I had to learn and I had to earn that, right? So all of our viewers certainly have the same possibility as I do, Anyway, so these are probably some of the most common connectors that you see, right?
Oh, yes.
And in the lower right, there's that 1450 we talked about. Actually, I think that's a 1460, excuse me. But anyway, close cousin to that. If we look at our NEMA chart, we can see where those would both line up there. There's a 1450 actually. But anyway, so a quick thing about colors, because colors are very important when we are looking at electrical wiring. We really want to stay only on the left. If it's on the right, we really don't want to play in that playground at all. If we look on the left, excuse me, you can see green, white, and black, the colors we find in our household extension cords and our household wiring. And that's what I mean. It's very comfortable to us. It's very common. Looks like the fonts didn't render quite correctly here, so these should line up. The ground being green on the top, neutral being white, and then our hot phases or our line phases being black, red, and blue. Here's the only thing I'm going to say about the colors on the right, which it looks like PowerPoint actually kind of messed them up a little bit too. But don't, right? If you don't see the colors on the left, it doesn't matter what colors you do see, don't mess with it, right? So, all right. So here's how this works. Here's my ground. Here's my neutral. Here's one of my hot legs, and here's another. And my voltage potential between hot legs is, in this case, 240. And between my neutral and my either of those hot legs is 120. This is on a single phase circuit. And then likewise should be the same from either of my lines to ground. So I have a good safety ground. What's happening here really when we do that is this. That's how that breaks out. Now, you wouldn't necessarily want to just connect a NEMA 515 like we see drawn here in the top to these, this 50 amp, 220 volt connector, because you're going to have way more capacity than you can reasonably use. You could, because 20 amp draw isn't going to trip that breaker, but that's really underutilizing that available power. You would want to have a distro, and you said, what's that? We'll get to that. Here's another example of like a three-phase disconnect, and here we can see that color coding and why it's so important, because a lot of times we're tying into the box. Again, not a novice move. But this is how three-phase gets converted down. And you can see it's actually really pretty simple when we break it down. Now, we talked about 240 before on the other one. Here we talk about this as being 12208. Why? And you'd say, why?
Why?
I just thought of that. That was pretty clever, huh? I mean, for being sick, I'm trying to be sort of with it, but I'm not. My brain's pretty foggy.
You're doing well.
This is why, because electricity travels in phases in the U.S. at 60 times a second. And we can see that at the peak of this wave to the neutral is 120 volts. But from phase to phase, no peaks ever align because it's 360 degrees. They're 120 degrees apart. So the highest point of the peak that matches the highest point of any other peak is 208 volts. So we have 120 volt single phase to neutral, and we have 208 volt three phase to phase. So pretty nifty. So what's a distro? You've been waiting so patiently. These are some examples of some distros. This uses what we call a California plug. You can find that used in a variety of circuits. Typically, we'd find this on like a 240, I think, but Oh, we switched our time back to 8 o'clock, and it's got a text from a viewer that said, "Hey, you guys already started without me. Sorry." So my bad. It wasn't my bad. It's John's bad.
That's
Blame
right.
John.
It's my fault.
We're back to our normal time at 8 o'clock. John knew I was sick and I couldn't make it till 8:30. So anyway, you can see where basically we would take that bigger plug from the outlet, and we plug it in, and then we have something that's more familiar to us times a lot that we can use, for our power stuff. So another example, here we can see definitely, for conductor 240 front and back, and you can see you got some 30 amp plugs in the back locking, and you got some 20 amp receptacles on the back. So and these are rack mount devices, right? They just live in your racks. My amplifier racks have 3-phase versions of these in them. I just plug in a 3-phase cord, powers my whole rack. These things come in all kinds of shapes and sizes. Here we can see one that's got a variety of things. It's obviously got feeder in. It's got a pair of neutrals because we might have too much capacity, going through here for a single neutral because it's shared amongst all 3 phases. And we've got all of our SOCAs and that sort of thing. Here's one that an electrician has made for a venue. And you can see this one's a pin and sleeve 60 amp, but it's got a bunch of different things that are more familiar to us on the bottom. So you could have an electrician make you one. I'll leave that between you and the electrician and the local jurisdiction. That's all I'm going to say about it. And then here's some other, all kinds of shapes and sizes, right? They come in all kinds of shapes and sizes, from rack interfaces to, other things. But a distro is basically something that distributes power. Big plug in, little plugs out.
And of course, most of them also had breakers in them on the front that you could access if something.
Very important.
Yeah.
Very important. And again, so if I've got, just excuse me, follow along here. If I've got a 50 amp 1450 receptacle and I plug a 20 amp device into it, I can go all the way to 50 amps before I'll trip that breaker. And that could be a real big problem for my 20 amp device. Again, it's perfectly permissible. But the point is, that's why you put those breakers in there. Because I don't want to have these capacities available to me that are, in excess of what that circuit is rated for. So that's why those breakers are important.
Excellent.
But just like you can plug a 15 amp load into a 20 amp outlet, you can do that. But when we distribute it as outlets to plug in additional loads, then we need those breakers, those overcurrent protection devices in there.
And I think there are some commercial devices that I have seen out there that were not to the high end of what you were showing us, but there are some where it has, I saw one at, I think it was at Home Depot, that had, it had 15 amp breakers on outlets, and it had either a 30 amp or 50 amp plug on it. And it was meant for kind of a camping situation. So
yeah, there's RV connectors and there's generator connectors. And again, I deliberately avoided those because I think it's kind of, buyer, not beware, but you should beware, but buyer be knowledgeable. Right?
Yeah, I think so. Yeah, if you don't know what you're doing, this isn't a good, you don't learn by doing in the field the first time.
Yeah, this is not an electrical engineering course, and obviously we want the show to be helpful, but in a litigious world, we have to be a little bit careful about what we encourage you to do. So
yeah.
John and I are doing this for free, so we don't want to get sued over helping you. So.
Yeah, exactly. So let's jump to our next question here, Ben. I'll lead you. So Ben, when I was doing some of my videos and specifically looking at some of these battery devices that we've seen in numerous videos, but I found that when I was running some of my DJ lighting, which is LED based lighting, that it seemed that was draining those batteries much faster than if I was running my sound system and such. And I thought that was the darndest thing. And I was wondering, I just would have assumed that my sound system would draw more, but why would lighting be a bigger draw for electricity than the sound system?
Well, I think it isn't always necessarily. Here's the it depends answer, right? But in the good old days,
35 minutes to get to it. I'm just saying.
Yeah, woohoo! In the good old days of touring, lighting used to be on 400 amp disconnects. Big, massive 400 amp feeders, because all that incandescent lighting just chewed up so much power, and audio was on a 200. And nowadays, we can run generally everything on a 200 because everything's so much more efficient. The audio is more efficient. The lighting's more efficient. I mean, everything is just, so much more efficient. In that spirit, though, there are things that are still significant current draws. Fog machines be one. They have, big heaters in them, right? That's going to draw way more power than LED lighting or audio. And there are some really powerful lights that, even though they're LED, they do, consume a lot of power. And we actually did an interesting show several years ago, as I recall, something like, can you get 1,000 watts from 100 watts or something? But anyway, it's a cool show people should watch about how much power does a 1,000-watt speaker really use? It's not 1,000 watts, really. Now, that doesn't mean you're being lied to, but, it means marketing is taking full advantage of the fact that you like a lot of numbers with zeros. But the reality is you don't listen to watts anyway. So go watch that show. I was one of my favorite shows because I thought we really did some, it wasn't really investigative journalism. It was simply just engineering that everybody already knew on this side of the fence. But, but it was cool to be like, hey, everybody, look at this. You're sort of being lied to a little bit, but only because you like it. You want to be lied to. You're like, yeah, tell us how many watts it is. Oh, for the love.
Yeah, because you want to be lied to.
Yeah, you do. You do. I mean, I'll tell you, and I've spent 30 years trying to educate people, and I love that the dialogue has shifted. I feel like that I have, I want to toot my own horn here, but I do feel like there has been a shift. There's been a change that started with a conversation with Ryan Berger at Mobile Beat going back about 20 years ago. And I said, we got to change this. People are just eagerly lining up to eat up the lies. And I said, we got to just blow the lid off this and go, stop it with this, nonsense. And the whole tenor of the conversations on the forums and the tenor at trade shows, I feel like has changed. And maybe it's just around me because of the circles I'm in, but I feel like that's maybe one thing that I would feel good about is giving power, pun intended, since we're doing a power show, but giving power to the people, giving the knowledge to our viewers to make informed purchasing decisions so they don't have to be lied to if they don't want to, Anyway, that didn't answer your question.
Yeah.
But I think it really just comes down to what you're running for lighting and what that draws, and then what your sound equipment draws, and the quantities of each. And, we talked about this a little bit earlier in this segment with the kilowatt, or something, a meter. This is just a really easy way to measure amp draw, and which is what you undoubtedly did, something like that. And you said, wow, look at that. This draws more than that.
Yeah.
The why would really come down to the individual device. So I sort of dodged all that because I felt like it was kind of irrelevant, even though it was your question.
Dodged the whole question.
Yeah, I'm sorry, John.
But it seemed as we were.
Do you want to be lied to? I'll lie to you.
Well, you could. But I think that one of the aspects, though, is most of our lighting does not have a level of capacitor in it, and many of our speaker amplifiers have capacitors in there. And I'm wondering if those capacitors play a role in being able to have a little bit lower consistent draw for the audio, and it can handle the spikes better, where the lighting doesn't have those highs and lows. It's more of just a consistent draw. So without the capacitors, it's just always pulling that much, where the speakers can pull this much because sometimes it's quieter, sometimes it's louder, but it can pull.
Well, we had a
That's
great
my
question
theory.
just come in from a viewer who's a good friend, and I think we should address it. So I'll throw it in, but I want to say that I think you're right on the money, and that's why I think people should watch that show about getting power. How much can you get 1,000 watts out of 100? Because that's exactly why. Without giving away the crux of that show, you should still really watch it, because I worked very hard on some graphs and charts. But anyway, I know everybody's like, "Ooh, graphs and charts, hold me back." No, come on, they're good, but. There's a thing called crest factor in music. We're not always using 1,000 watts. In fact, very, very rarely are we using 1,000 watts. So we can have this lower level draw that's stored in those capacitors and other, devices that allow us to feed surge power out, peak power out to our driver when needed. And I think you're right on the money there.
And for those of you wondering, I'm going to put the link to that show in the chat.
I haven't watched it, I think, since we did it, but I just remember it being one of my favorite shows.
It was,
so
for those wondering,
so everybody,
it's 2019. We did that one back Back 5 years, literally almost 5 years ago, May 14th, 2019.
Oh, wow. So I haven't watched, I don't remember. So I guess everybody can watch it. And if you're like, you know what, Ben, that show actually kind of sucked. Let me know. Just send us a message and be like, hey, I don't know why you remember it so fondly because it was terrible. But I felt good about that show. I felt like we
did. We covered some good information on that one. That's one. There's some that you forget just because, we've done similar versions, but that one, because it was
over 300 now, I think, right? We've done over 300 shows.
We've got a lot of them out there.
That's bonkers. That's nuts. To the viewer, can I ask this question? Because that's something I can do.
Just let's put a break in here for edit points.
All right.
Okay, so Ben, what do you got for the next question here?
This just came in from a good friend and a viewer, and he says, one, you sound like you feel like.
There is that.
Yeah, crap. I do. Thank you for noticing. But nothing's going to keep me from helping people here, right? So even though I'd rather be in bed feeling sorry for myself, and more importantly, getting my wife to feel sorry for me, that's really the ultimate goal, right? But I'm here to help you improve your shows. So, but thank you for noticing. I'm looking for the sympathy, so I appreciate that. So, in lieu of flowers, please just send likes or something. I don't know. Anyway, so the question that he asks is, I hate to lose a gig because I tell the client I need two 20 amp circuits and all they can provide is one 15 amp. How can I be sure of what I need? And he says, maybe you covered that in before I tuned in at the scheduled time. I didn't read the whole message before I read it live on air, so I kind of missed that. Yes, we went back to our regular time at 8 o'clock. Sorry you slept through it. Anyway, so I have to be careful. This friend knows where I live. Literally, he actually knows the door code to my house. So I think what I would communicate to the client, instead of, I wouldn't hold firm and say, if I can't have two circuits, I can't do it. I think I would just communicate to them and say, well, the limitation is yours. You're the one who doesn't have enough power, and that's no problem. I can accommodate, but I can't do this, right? I can't just make magic amps appear out of the wall. So, and we did address this a little bit earlier in one of these segments, but about measuring, and I just mentioned this device because it's cheap and you can get them everywhere. And I'm not an endorser yet. We've been trying for 10 years, and I guess I'm never going to get it. But anyway, so I don't even know who makes them. But anyway, Kilowatt is the name of the product on this one, and you can plug your stuff in and plug it into the wall, and you can see how many amps it draws. And you could kind of add that up, and you could do a little bit of system budgeting, kind of like if you watched Apollo 13 with, Tom Hanks, great movie, but they're budgeting so they don't trip breakers when they restart the LEM, right? This is the weird stuff that pops in my head when I'm sick. Sorry.
Yeah, that is kind of the weird stuff. Yeah.
Isn't that the best part about being sick though, or like the crazy, dreams? Anyway,
no, those are bad because then, yeah.
I should, if I could remember them, I could write a movie and retire. But anyway. So that would be it, right? Is learning what those limitations are. How hard can you hit the sound? What can you bring? What can you do for lighting? And then communicating that to the client and being accommodating. And certainly that's something I do in my workaday. Not every show is an arena show. I have to be somewhat conscious of what we're doing in a small ballroom or, an outdoor show or, an outdoor not a concert, right? Where things have to be tailored to fit. And that's exactly what we do. We say, well, this is the, amperage we need, and this is what the client wants for results. And can we balance the two? And if not, then we have some real conversations. If the client says, oh no, I have to have this, and you're like, well, then you have to have a generator, but at least the client understands the limitations. And I think the punchline to all of that is that you might lose the gig. But if you do, you're gonna lose it to somebody who doesn't know, and they're not going to deliver, and that client's never going to make that mistake again, and you're going to look like the hero. Chances are you won't lose the gig. Chances are, I think the client's going to appreciate the homework you did.
So you mentioned, of course, when old school lights and old school sound system using all that electricity. Now you're basically able to use maybe a third the electricity you did at one time because of efficiency. What type of things within the DJ community, because obviously we have LED lights, we didn't have that. We have more efficient digital amplifiers that we didn't have before. But what are some of the still high draw items that DJs might be using out there that they should be aware of, that if they're utilizing that and their sound system and a little bit of light show, that they could have problems?
foggers, hazers, spark machines, anything with, heaters or compressors or, industrial motor type things going on. I mean, anything like that are going to be the highest draw by far. Anything that's incandescent, if you still have any incandescent lighting effects, halogen, whatever. But that's really it. I mean, I think, by and large, everything else now, most of your amplifiers are Class D, Class H. They're super efficient. We're talking about 1 amp draw, 2 amp draw for a pretty decent speaker. You can get a lot of stuff on a 20 amp circuit now. You can get a lot of stuff. And I think, again, if you start measuring that and adding it up, and I don't know how everybody else rolls, but me, I've got databases of this stuff, so I don't have to look it up twice, right? I don't want to do the same work twice.
For sure.
Then it's just a matter of tabulating, all the things that I have in a show and looking at a total amp budget.
Mm-hmm. And seeing if there's going to be enough possible to do what you need. Yeah.
And always give yourself a safety ratio, right? You got a 20 amp circuit, and if you come up with 20 amps load, I don't like them odds.
Yeah,
I'd give myself, 20% cushion or so, So anyway.
Excellent. Let's try to get one more question in here before we wrap for tonight. All right, Ben. For our last question is...
That's good, because I still feel terrible.
Yeah, you're making it. You're getting there. You're getting us there. You're doing a great job tonight.
Thanks for hanging in, viewers. Appreciate you.
For protecting our gear, people have talked about, and we've already mentioned a couple of things in some of the other videos you guys will be able to see where we talked about surge protection and things. But if you wanted to invest in a couple of pieces that would really protect your DJ system when you're out in the field, what are a couple of things you could recommend or things that they should be thinking about to protect their DJ gear from electrical issues?
I think there's some obvious ones and there's some maybe not so obvious ones. Okay. I would say I'll start with the not obvious ones because I think those are maybe the most beneficial, right? Or at least the most groundbreaking. Good cords, good cables, good quality connectors. That's going to prevent failures, which could prevent arcing or poor conductivity, which will cause additional draw problems. You're exacerbating all the problems you have otherwise maybe. So good cords that are sufficient gauge to carry the amperage. We're not having significant volt drop problems if we're running long cords. We're also have cords that are able to handle the abuse and the ends aren't, getting beat up and the connectors aren't losing that, good connectivity. So I think that's a key thing. Mm-hmm. Properly grounded equipment always. And that's not just for the longevity of the gear. More importantly, it's the longevity of you. Of all the pieces of gear in your show, the most important one is you. You can do your show with probably just about any other piece of gear. You can't do it without you. So, it's not your show without you. So grounding is very important to protect your gear and you. Beyond that, I would say there are times it's a really good case for things like a good power conditioner. Some of our lower current devices that are more susceptible. I don't worry about them so much with things like, fog machines and stuff like that. They're pumps and heaters. I'm not really worried about that. There is some circuitry in there, but I'm not necessarily worried about that. Even speakers so much, I don't really worry about those. By and large, unless you have a pretty significant transient, I think they're pretty solid. I would worry about it a little bit more with more sensitive devices, things like, projectors, things like that. DJ controllers and things like that. I mean, this might sound extreme, but one of the things that I would probably find beneficial and one of the things that I always use on a mixing console when I'm working is a UPS, a battery backup. Because, one, if that board goes down, most boards and most controllers now are basically computerized devices.
Sure.
They're generally pretty tough. They usually come back up. They usually reboot, right?
Usually.
Yeah, but usually isn't good enough.
That's not a guarantee.
And if they do, I'm probably losing a lot of settings anyway, right? So I don't want them to go down. Mm-hmm. I want to keep that up and running all the time. So for me, keeping that console from going down is a really big deal. Particularly with some of the consoles that we have, even and really the most expensive ones, the reboot time is significant. If your console's down for 5, 6, 10 minutes, that's a long time in a 75-minute concert.
Yeah.
That's the kind of stuff that gets you on TMZ, or YouTube. But, so, for the sake of having a battery backup, and again, that's hoping your console comes back up. DJ controllers are kind of the same way in some regards, right? I think it's not necessary, but I would strongly consider it if I was using a DJ controller. I would have a battery backup, I think. Now, you might say, okay, well, what about my laptop? Well, laptop has a battery built in, so no, I'm not worried about that at all. If you're running a desktop, which I know some of my DJ friends do, yeah, I'd definitely have that on a battery backup. I mean, if you unplug the power cord on a desktop, lights out, baby. You're going to be waiting until it reboots. And those are usually the times it decides to do a software update, right? So,
Yeah.
so let's not have that is my point, right?
Oh, funny. So we've talked about also some devices out there on past shows that would actually clean up some of the buzz and some of the things within the electricity. Are those devices that are readily or are available for a mobile DJ to add to their system? Or there's
Yeah, absolutely. There's really good, and we looked at in one of our previous segments here. We looked at the difference in power conditioners, and on this channel, my friend Chris and I did a show on power conditioners, and then you and I did one a few years before that. Really good look at what's under the hood and what makes those different, and we even talked about a little bit of it tonight. Different size and form factors, but even really little ones, like I think it's the AC 215, if I remember correctly. From Furman is a pretty good unit. And it's just a little box, like about this big. You could stick it, behind stuff. It was actually designed originally to go behind TVs and installation. That's what they intended it to be used for. DJs are always surprised to find out that not every piece of AV gear is made for them. In fact, newsflash, you guys are like 5% of the market, so most of it's not made for you. But hey, that's a good thing. Just take advantage of the fact that somebody else designed this and paid for it, and you get to use it, right? So AC 215, I think, is the model number. But otherwise, you could go with a good, classic series, something like that. Those are really good. There's some other really good ones out there. Middle Atlantic makes some really good ones. Atlas makes a half rack that I think is pretty good. Even, some of the less featured that don't have the non-sacrificial circuitry, there's the tour bass from Diodario. There's the SS6B from Furman. Some of these more industrial power strips, have some noise reduction capacity in them, chokes and things like that. I remember shooting a video on the Diodario power bass, years ago when it came out. Tour power bass, that's what it is. I don't feel good today. I'm sorry.
You're doing well. We're just about there.
And literally, we had a radio signal coming through when we were about to shoot the video until we plugged that in and it got rid of the radio signal. Like, man, I wish we had staged that. Like, that was the greatest thing. And we tried to caution people that it wouldn't necessarily solve that problem for everybody. And sure enough, somebody bought one and it didn't get rid of the radio signal. Yeah. And it's like, listen, there's a lot of ways a radio signal can get into your gear. If you lift the ground, you create an antenna and, it could be coming in a mic cable. But anyway, it was just neat to see that actually work right as we were about to shoot a video talking about this product. We're like, hey, that was worth $30 right there, you know? So,
and again, if people
results may vary.
if people are looking for some devices like that, a phone call up to the office, and you guys can kind of walk through what their needs are and help them with that.
Yeah, I think engineering, it's always a series of compromises, and we could talk about that, right? If you're getting some of the control towers, things like the bun booth, that sort of thing, they're not deep enough for some of these really pro power conditioners. So, then you're relegated to using the lesser ones, but that's a trade-off, and that's okay. Say, all right, I'm not going to have that level of protection, but I also don't have problems at my show. So check, good, right? Yep. It's not a problem until it's a problem, and generally it's not a problem. You can use those less expensive ones to solve the low level problems. And we'll kind of walk you through that. I mean, to your point about calling us, we're not going to, BS you, we're going to be pretty honest. As Norman Schwarzkopf said, by the way, it's bovine scatology. That's what BS stands for, bovine scatology. Anyway, but we're just going to give you the plain truth, right? We believe in long-term relationships. We believe in helping people and earning their long-term business and not trying to make a quick buck.
Excellent. Links for the different shows we've talked about should be in the chat. You guys can go and find those. The power conditioner one, the one we did about the wattage. And of course, if you are looking to add some things, go check out the NLFX Pro website there, and the phone numbers are there, and you can give them a shout during business hours in Central Time Zone, because that's where we are. Yay! Ben, we got to go. The guys
thank goodness. I'm going to bed.
Yeah, you guys are getting ready. So thank you for being with us tonight. And Ben, thank you for getting out and doing that. And even though you're feeling not so great tonight, but it was good information.
My first sick day in 2 years, you know, I mean, it's whatever. I mean, you know, I could suck it up one sick day in 2 years.
Yeah, well, we made it through, so wonderful. Thank you guys for being with. And again, DJNTV.com/chill. You can go out and check out the Tuesday Night Music Show Zoom Room and have some fun this evening. We'll catch you next week. Good night, everyone.